Okay, it says a certain tennis player makes a successful first serve 80% of the time. Assume that each serve is independent of the others. If she serves 9 times, what's the probability she gets all 9 serves in, exactly 6 serves in, at least 7 serves in, or no more than 6 serves? Okay, now we have a Bernoulli trial here because she either gets this shot in or not, the serve in or not. The probability of a success, P, is 80% or 0.8. In this case, we have a fixed number of trials. So that tells us that we're dealing with a binomial distribution, and the fixed number of trials, n, is 9 here. So to answer the first question, you have 2 ways to do it. You're asked to figure out what the probability is that she gets all 9 serves in. Well, if you're just having a good day, you might realize that that's just going to be 0.8 to the 9th power, because each slot, if you think of it in terms of slots, you have to get 0.8, 0.8, 0.8, 0.8 9 times, so you're just going to use that multiplication rule. So it's going to be 0.8 to the 9th. Now, another way you could do that is with the binomial distribution, because we're going to be using that later on, so we'll go ahead and go over that. And the big thing to understand is whether, kind of how you want to use this function. Now, this binomial distribution will return the probability either at the moment or accumulation of particular trials. So in this case, the number S is 9 because we want to get all 9 in, and there are 9 trials. The probability is 0.8, and we can put a 0 for cumulative because we don't want it to accumulate. We want it to just be at exactly that moment. So we put enter. So notice you get the same answer. So either way on that one particular problem works. The 0.134. Now it says find the probability she gets exactly 6 serves in. Now I'm just going to go up and modify this binomial distribution command. Now we only want to get our number S is going to be 6. We're still going to have 9 trials. The probability of success is 0.8, and we don't want to accumulate here. We're just looking at for exactly at that moment, so we leave that cumulative thing 0. So then we get 0.176. Okay, now the probability that she gets at least 7 serves in. Well, the probability of at least 7 is equal to 1 minus the probability of 6 or less, because the complement of at least 7 is 6 or fewer. And so how do you do that then? Well, you come in here and you'll do equals 1 minus, we can do 6 or less because that's going to be accumulation all the way up to 6. So we'll do our binomial distribution function. And the number of trials that we want here is 6. The number of successes is 6. And actually, we're going to end up doing on the cumulative part, we're going to end up putting a 1. And the reason we're going to do that is because we want to know, could you have 6? Could you have 5? Could you have 4? Could you have 3? Could you have 2? Could you have 1? Okay. The number of trials that we're looking at is 9. The probability of success is 0.8. And in this case, we're going to put a 1 there for cumulative because we want to accumulate it up. All right, and so that answer, 0.738, is probably she gets at least 7 serves in. Okay, the probability that there are no more than 6 serves in means no more than 6 means 6 accumulation up to 6. So you can just do equals the binomial distribution, and your number of successes is 6. We have 9 trials. The probability of success is the 0.8, and this is going to be a cumulative distribution because it's no more than 6. So it could be 6, 5, 4, 3, 2, 1, or none. So we'll put a 0 there for cumulative, and then that's our answer, 0.262.